An open box is made from a square piece of cardboard 40 inches on a side by cutting identical squares from the corners and turning up the sides. A. Express the volume of the box. Now we know volume equals length times width times height of a box in simplified form, meaning no parentheses, of the length of the sides of the square cut from the corners, from each corner x. So the length cut from the corner is x. Then lastly, find x that would result in a maximum volume. Find the maximum volume and round to the nearest tenth. So here we ask you to round. All right, so real quick, let's start out. If I've got some square piece of cardboard that's 40 inches on a side, and I cut squares out of the corner, and those squares out of the corner are x and x. The length of my sides here and here are now going to be 40 minus 2x. Okay, so I now have a box that looks like this, right? Where the height of this thing is x, 40 minus 2x, and 40 minus 2x on the sides. So I'm still working A down here. The volume is equal to x times 40 minus 2x squared. Simplified form is what they wanted, so we got to do some multiplying. X times 1600 minus 80x minus 80x is minus 160x plus 4x squared, and we're going to distribute the x, and I'm going to rearrange that equation at the same time. 4x cubed minus 160x squared plus 1600x is my equation. That goes up here. V of x is equal to 4x cubed minus 160x squared plus 16. Let's write that so we can read it. 1600x. All right. Find the volume, or find x. That would result in the maximum volume. Okay, so notice that we've got a situation where we've got a cubic function, right? We know that if I solve for 40 minus 2x, right, we're going to get x is equal to 20 and x is equal to 20 and x is equal to 0. This is a positive odd. So my graph is going to come down from the right. It's going to bounce at 20. It's going to come up. It's going to come back down. And it's going to come through at 0. It looks like this. Okay? And we're looking to find the maximum volume. The maximum volume will not be in this area because that never gets to a maximum height. It will never be in this area because that's going down below. That maximum volume has to be somewhere at the peak here. And this is where you plug this into a calculator. This should have said graphing calculator permitted. I didn't delete that. Sorry about that. So you're going to use the calc function on the graphing calculator. You're going to put your arrows here and here, and you'll find out that your x value equals 6.6 repeating when your y value is 4,740.7. And this is inches cubed. This will be inches. So x 6.7 to the nearest 10th inches. And volume 4,740.7 inches cubed. And again, that's a calc function on the graphing calculator.